Good afternoon, dear participants. The Dr. Pakray is with us again, and he will continue from his yesterday's lecture. And we are fortunate enough that Dr. Pakray is ready to give a hands-on session on the same topic. So, without taking much time, I give the floor to Dr. Pakray and his PhD scholar, Mr. Shambabu Pandey, for the hands-on session. I welcome you, sir, to our fifth day of this program. Thank you, sir. You can.
Thank you, Saurabh, and thank you, madam, for giving me an opportunity for the second session. So I'm sharing my slide. Thank you, madam, for giving me an opportunity for the second. So good afternoon, all participants here. So today I'm going to discuss on machine translations and one. So you can see, is it visible?
Yes, it is visible and you are also audible.
Okay,
Perfect.
okay. Thank you.
Okay.
So you
Thank
can
you.
see that today's topic is basically machine translation, which is very important nowadays. You can see everywhere, everywhere you can see that part. Not only that, like text to text, as well as that there are lots of needs the video translation also, because that nowadays NEP also, like they are translating that video local languages. So the video means basically for the educational translation video. So it's a very important domain nowadays. And if I ask you this question, so how this machine translation is easy or complex? Easy task or that complex task?
It's a complex one.
Oh, of course, it's a complex task. It's not so easy to do that one. So there are lots of things you have to take consideration of that one. So we'll see that part. So in this session, basically, I'll discuss the some of the challenges, various types of the machine translation, what kind of evaluation matrices are there, and that world and the India, how the research is going on in this domain, as well as that evaluation tracks there are where you can get the data, as well as I will discuss some of the message translation tool where you can start your some baseline system, and finally there are some of the current trends, and then you can start your future direction. You can start working on that one, and another research domain you can start working on that one that is really interesting in the AI, that is called the recent studies, basically gender disparity. So how the gender biasness is there, that like translation, natural language, any of the natural language processing tasks. So I will discuss that part. So, but it is in brief thing, not in broadly. And there are few researchers are working on basically in this domain. Now then I'll give some of the references on that recent paper, so from where I have taken this all the slides from you. So as you know that, of course, that machine translation, as you know that one translating from one natural language text to another natural language, of course that human spoken language, whatever I am talking about that one. And everybody seeing these things, Google translation. So of course that it was launched on that 2006 officially launched, and basically it was on the statistical machine translation system. So you can see that this particular term, the statistical machine translation system, I will discuss that part later slide. So then 2016 you can see that Google announces that another translation system, that basically neural based machine translation, because of the 2000 12, 13 and 14, these duration, like year of this duration, mostly like deep learning concepts came and implemented in the various domain, of course. So that time it was launched in 2016 November. So neural based machine translation was launched, and you can see that some of the few recent language also, like northeastern languages also added in the Google translation, and you can see that Times of India also, like some of the zero shot learning also added in that one. So I'll discuss about that one, how you can work with that zero shot machine translation. So later slide you can see that part. Okay, so now thing is that based on the resources, that because whenever we deal with any of the machine translation system, so we need the resource. Without the resources we cannot that in that case we can classify that two types, high resource language and the low resource languages, basically for that getting the corpus, getting the tools, number of speakers, that based on that then we can classify that that high resource languages and some of the low resource languages also there. Okay, so you can see that some of the high resource, of course, like English, German, French, the Hindi, these are the high resource language. You can say like lots of tools and parallel data also available. And the low resource languages, you can see that some of the northeastern language and some other states also there are various languages are there. So we can classify as an low resource languages. And now, of course, that if I ask you this question, so of course that is machine translation easy, hard or easy? Of course, it's not so easy to do that one because there are lots of things to consideration. So what are the challenges? What are there? So some of the challenges, of course, previous slides also last session I had discussed with that one. So of course you know that part like lexical ambiguity. Of course, this part I already discussed that polysemy words creating some of the problems. And apart from that, the most of the problem is the like kind of inflection kind of thing. Sometimes the numbers are there in the books and books singular plural, and then the gender oriented thing and the case oriented thing and the tense also, that how you can deal with the source and target, because we are translating from the source to target. So we have some source language and the target language, so that mapping is the very important, how you can map with that source and target part. So these things you have to consideration of that one. And not only that one, sometimes some of the articles also there, you can see the some of the articles how they can map or how they can align with that one. Alignment is the most important part. So you can see that sometimes some of the language does not exist any article, so in that case how you can map with that one. So in this case you have to take care that how your system can align during the training period. So how you can do that, and that part basically. So then the prepositional part also there, including with the prepositional relative pronouns also there, because pronoun can create a problem, because of course like he raised his hand, so there will be some problem will be there. So because of the some of the language, whenever you translate one source to target, basically some of the language dependent on the gender part. Some of the part is the gender part is there. So anything, any questions? Okay, no. So anyway, so next is the conjunction. So conjunction is the between the two phrases or two words. So of course that is also the problem for that one. And another most important part is that syntactic translation problem, like subject object verb projection. So how you can align with that one, like subject verb object or object subject verb, how you can do this word order. Basically word order is the very important, because once you translate with that one single word, and after that word order, which word order it will come first, and after that which one will come. So that is the most important part for that syntactic translation problems also. So we can I have taken some of the data from the Wikipedia, so you can see that subject object verb is like most of the languages cases are 45% cases are there, like that this kind of word order they are following, and the SBO is the 42%, and rest you can see that verb subject and object like that 9%, and then verb object subject 3%, and object verb subject so like 1%. So like this way these are the various languages are there, so you can go through that part, so you can get it. Like this way it can follow. So whenever we translate, so from source to target, of course that target language how it is the word order follow, how the source language is word order follow. So how we can do that part. So that is another important challenges of that one. And then the phrase translation problems also another important thing. So sometimes idiomatic phrases are there, so sometimes hidden meaning also there, sometimes jokes also there. So in that case is translation is very difficult from source to target. And then semantic ambiguity also there. So previous also I already discussed some of the phrases or some of the words meaning may change. So how your translation is giving for the particular word or phrase for the semantic meaning of that a particular one. So that is also a challenge part for the message translation thing. Okay, so apart from that, there are some of the other issues are there. So some of the other issues is like you can say like long-term dependency problems also there. So whenever we have a source sentence is very long. So in that case, of course, human also made a mistake. So if I say you some of the longer sentence and you are translating something, so of course we sometimes some part we missed that part. So how we can train the system? So how we can get it like by the system? So that is also another challenging part. And the context analyzing ability. So whenever of course the long sentences are there, which context I am telling, so how it can be translating. So that is also another challenging part. And the most important part is the low resource languages thing. So high resource languages, you can train the system by using that. You have a availability of corpus, million billions corpus, you have that one. But problem is that whenever you have the low resource languages, how you can follow the alignment. So that is the most important part. So if you have the less data, of course alignment is very difficult to do that part. So low resource language is the most challenging task, and nowadays many of the researchers are working in this low resource language. You can see if you search in there are many dialect languages are there, so you can see that part there. Many of the researchers are working in this domain. So apart from that other thing, you can see that whenever the translation is hard, we can say some of the cases like novel translation, wordplay, jokes, these kind of also like, and not only that, lyrics, poems. So this, and of course the sentiment our text. Sometimes some of the sentiment related text also, translation also very difficult to do that part. So still there are lots of problems. So in that instead of the art systems also, so like Google translation as well as the Bing translation, so there are these kind of things. So it is also very difficult to translate for that one. Now if I ask you this question, so like how the humans do translation, so what will be answer for that one? Because systems, so similar way how you have to train that system, but how humans can do translation? If I ask you this question, so if you are you able to answer this question? So how generally we can do whenever we know the two languages? If we know the two languages, how we can translate? Or if you know the new languages, so suppose if you want to learn so Spanish, so how you can do that English to Spanish translation? How you can do, what steps you are following generally? Any idea? Like if you learn the new languages, so what you follow for that? Okay, so I can give you, so of course that how to learn a foreign languages. So whenever you learn the new languages, of course you have to do like some of the words to the memorize to that one. So first you know some of the word, how to memorize that particular word and what is the meaning of that one. And then you have to learn the pattern means how you can form the sentences or form the phrases kind of thing. So learn some of the pattern. So once you learn the pattern, so then you have to exercise that language. Okay, so these are the things. So how you can do that part? So that you have to do that exercise of course. How you can do, either you can read, listen, or write that particular languages. So write and speak, so you can improve with that one. And then of course that once you learn these things, so in after that, if I ask you to translate some of the sentences, of course you can understand that particular sentences. And then of course that they of course you can clarify, or you can ask some, if someone can ask you, of course you can translate easily for that one. So our brain, like this way we can follow the pattern. But how the system will do, system also the similar kind of steps also there. So that is called the training stage. So you have to train the system. So how you can train the system there? You need some of the parallel corpus, or you need some of the corpus for any of the particular application of NLP. So of course that one. So training stage, you need the translation lexicon, or the transfer rule, or that whatever the templates are there. So these are the things are required for the during the training. And after that, so you have to, once you get the data set, of course you have to apply some of the learning algorithm. So learning algorithm, how you can do that, some of the rule based things, some of the statistical based things, some of the neural based things. So what kind of learning algorithms are there? So you have to do that one. And once you do that part, once it translated that particular source to target, and then you have to redirect with that one. And the decoding stage, that is called the decoding stage. So once you decode that one, so how you can align with that one. Align means of course that with the source to target, how you can align with that one means how is your position, subject, verb, object, and how you can do that you can use some of the parsing, semantics analysis, you can do it. And then finally you can word level phrase, you can do it by word level or the phrase level, and then you can generate the meaning of that one. So this is the overall concepts of that systems and the human. Generally we can do that part. So now going for that, what kind of basically the resources are required for the machine translation part? Of course, like we need the some translation lexicon, that need the bilingual dictionary, and of course that if you have the bilingual dictionary, so that will really help you as a parallel corpus. And if you need some of the rule based techniques, so in that case you need that transfer rule, like transfer rule, how it look like in this source, and that what is the what will be the transfer rule for that target thing. So you have a source language is like English, and the target is that Hindi. So how, what will be the transfer rule between that one, and what kind of template you can use for that one? So that can be provided from the grammar books, or linguist can provide you that details of that transfer rule. And apart from that one, of course, that most important part is the called the parallel data. So parallel data during the training, statistical as well as the neural based training, so or EBM system. So you need the parallel corpus. So to generate the rules, so some of the rule you can generate or you can find by using the SMT or NMT. So you can use for that one. And not only that one, if you have that other tools, so you can use for some of the word name, frame name. So if it is needed, not always it is required. So NLP tools, sometimes it is mostly required that tokenizer, morph analyzer, parser. Tokenizer is the most important part, because that if you do not have the tokenizer, so in that case there are lots of problem. In that case, sometimes symbol can attach with that particular word or a particular phrase, so it can be attached with that one. So you have to split with that word, tokenize that word. Then morphological analysis also there. So sometimes previous class I told you some of the words may be some agglutinated words, so you have to find some of the root word finding from that one. So in that case you can use for that one. And parser can generate some of the syntactic tree structure, so you can dependency structure tree, you can generate that one, and you can compare with the source and target for that one. And now these are the basic things are the important for that machine translation challenges, and these are the resources are required. And the most important point is that one of the component is the most important part is called the language modeling. So last class I told you that the language model is the most important. Nowadays you can generate that one. So how the language model can also help in this machine translation, so I can give you some one example, so you can understand that how the language model can help to improve the result for that any machine translation system. So but it was introduced long back, it is not the new thing. It was introduced after 1990s. So yeah, this language model concept was introduced, and it was used first in that SMT, statistical based machine translation. So they many of the researchers use for to improve their result. Of course it is help to improve that result. So you can see that Gmail, we can see that in the Gmail also we can see some of that phrases. Whenever we can type it, you can see some of the hidden text always come like this way. So how this predict, why not other word came on that one? So how it is predicting that one? So always we can see that part. Not only that one, in the chat GPT also, that it can generate the new sentences also. That so I can give you some of the small demonstrations, so you can take your pen and the copy also. So I can later on you have to calculate some of the probability value, and you can understand that part. So simple example I can give. So you can see another example like probabilistic. This is called the probabilistic model. Of course, that how we can do. So if you have the two sentences, so suppose the two sentences translated by your system. So one sentence is the high winds tonight, and another one is that large winds tonight. So of course that high winds tonight is more probable than the large wind tonight. So this is the this probability value will get it higher than this probability value. Now I will tell you that how to calculate the probability value from the corpus. That why I'm telling you that this probability value is the higher than that. How we can calculate that one? Not only that one, we can use for the spell checking also. So you can see that which one is the more probable for that one. So we can use for the spell checking also there, and the speech recognition also we can use. Not only that one, summarization, question answering, these things also we can use for that language model. And in all domain, means in natural language processing nowadays, even machine translation also mostly dependent on this language model task. Now how we can do this part? So this probability model, how it can possible. So main thing is that you have to compute the probability of a particular sentence or the sequences of words. So whenever that sentence has been given, of course that there are some of the word sequences are there. So W1 to Wn. So these are the word sequences, any of the sentences. Now you want to predict, like you have that word sequence 1, 2, 3, 4, 5. Now you want to predict that W5, what will be the probability value of that one, which value will come to that one. So in that case, that future words is the W5. So you have to calculate with that W5 given by the W1, W2, W3 and W4. So based on that, you have to calculate the value. So if you have the W5, 5 words are there, you calculate that 5 probability, and then highest probability you can take consideration that this will be the next probable words for that one. So this is called, that whole thing is called the language model. So you can see that nowadays n-gram language model, you can understand that sometimes n-gram language model. So n-gram means like sometimes whenever the one word there, so that is the unigram. Sometimes 2-gram, whenever you compare with the 2 grams, of course that bigram, diagram, three word diagram code, and then number of n-gram model you can compare with that one. Okay, so this will help you to do that one. So now you can take your copy. So I can give you one example. So how you can calculate with that one. Of course, current word with the previous word. Current word given with the previous word. Probability of the current word is anything questions? Yes. Someone asking the questions? Amandeep, you raise your hand. Any questions? Okay, anyway. Okay, so you can see that how you can calculate that I mean the current word given with the previous word. So you can calculate with that count number of words, like if your sequence is like previous word and the current word, and given by the total number of previous words. So from the corpus, basically it will calculate from the corpus, and this language model is mostly dependent on that monolingual corpus. Whatever the monolingual corpus you have, that one. So if you change the corpus, and your probability value may change for that one. So how it works, so you can see that this is one exercise. So we can do the in this session, so for few minutes, 3-4 minutes, then we can move to the other slides also. So you can see that there is a corpus has been given. So you just look into this one. So there is a corpus given, not this table. So only the corpus has been given. So you have these starting and ending tags are there, and there are some of the corpus. All things you can see that it is stored in the text file. And then if I ask you the question, so that if your starting word is S and then second word is the do, so what will be the more probable word from this corpus? What will be the more probable word? So should I take starting node? Should I take the I? Should I take am? Should I take Henry? Or should I take like? So what will be our most probable word from this corpus? So how to calculate that part? So in that case, you can do what you can do. You can do it like you can calculate first of the frequency of that each of the word. Of course, that you already get it, like number of. You can see the total number of 7. You can get it, and a single word you can see that just calculate the frequency. And now how to calculate that one. So if I take you taking all the unique words apart from the S, so we can take it all the unique words. So if I take it that the ending node given that do, so what will be that probability? So of course that in that case if I say like if you see that one, so previous word and the previous word with that current word, the like U and S account, and the denominator is that number of previous word how many are there. So you can calculate by using these things. So you can see total value is like kind of 0/4, and like this way you can calculate all the values here from next word, and then you can see that which one is the most highest probability value. So of course you can get it that 2/4. Of course you can choose that one. So your next word maybe your I will come from this corpus, and then you can say like okay, so I can choose this particular word, so not other word. So it is the highest probable word. And of course it may change. It may change for that one, because if your corpus is again changes, then again it will change for that. that one. So that value may be changed. It is not fixed that this exact this probability will give. If your corpus increase, your probability value change. It may change other words also. So like this way you can see like how we can predict with that one S starting node, and then I like Henry. So what will be the next probable value? So you can calculate like that one. And now you can see another interesting challenge is that so if I say like two particular sentences, I have that one. So what are the sentences? So I have these particular sentences like this one and this one. Okay, 1 and 2 I have given to you, and then I can tell you. So can you tell me that which one is the more probable based on this corpus? So you have to calculate. Like I want to choose only one that is the more probable to compare with this particular corpus. So how you can do? So of course you can calculate the probability value of each of the sentences. Like S, of course you can calculate that I given S, then Li given I, then college given like. So like this way all combination, and first you can take it as an one. So before that there is no word. So of course you can take it as an one multiply with that whole probability, and then you calculate the whole probability values with that one, and then you can get it some of the probability values with that one. And another one you can see that do I like Henry. So you can see that these particular sentences you can get it like that. So from this particular calculation, of course I can get it like highest probable value. I can take it as an this is the most probable value. So of course our output is like that. So these things is usable for the machine translation. So this language model is help to detect that. Okay, so should I choose this one or this one? So in this case, of course I will choose this one based on my data set, not the other data set. So like this way it can calculate, and then it can says like so more probable kind of thing. So next word, and as well as the not only that one. So bigram is only the previous word, and then trigram, program, you can compare with that one, and you can get that result for that one. Like this way you can compare with that one. Even another example you can see that how I can calculate with this particular probability value for that one. So you can get another examples from here. Okay, so these are the things. So understand this part up to this. Any questions? This language model will help to increase the accuracy of a system. So how? So that I will explain the next slide. Yes. Any questions? Okay, so I can move to the next slide. So you can see that there are various approaches are there. You can see that there are various approaches are machine translation. You can see that some of the applications are called the rule-based technique, and then EBMT, then SMT, then the NMT. So these are the thing introduced, and long back rule-based technique introduced around 1950s. Of course, it was started around 1970s. These duration mostly worked on that rule-based machine translation system on that one. So the category of that rule-based machine translation is like direct machine translation system, transfer-based machine translation, and the interlingual machine translation system. So then around 1984, so that time it was introduced that EBMT system. So that time that data-driven approach was started, and then the 1990s, so this duration statistical based machine translation was introduced. The most important part, there are various types of the SMT, that is called the word based statistical machine translation system, syntax based machine translation system, and the phrase based machine translation system. So there are lots of statistical machine system. You can see that one 1990s to 2000 around. Of course, that 2006 first launched the Google. So 2006 and 7 this duration it was launched the SMT based system. Of course, around 2013-14 duration, of course, it was launched by the NMT. So up to that 2015 is officially many of the researchers are working on that neural based machine translation, basically for the RNN attention based self attention and the transformer based model. Basically, they are using for that one. So these are the categories for that overall history of that machine translation system. So you can see some of the of course the rule based system is like a set of rules. It does not depend on any of the data sets. So whatever the rules are there are some of the transfer rule, like what will be the Hindi to English to Hindi translation. So what kind of rules may follow? So if like these things, and so what will be that one if and then kind of thing. So if and else kind of thing, so we can do that one. So there are some handcrafted rules are defined, and based on that, direct based machine translation done. Then the transfer based machine translation, and then interlingua also there. So we can see here direct based machine translation is basically for some of the dictionary based approach is there. So basically whenever you have some of the source word, and then what will be the target word, and basically you can map, and then what will be the mapping technique, just reflect with that one, nothing else in this direct base. And then the transformer base is basically direct base is basically work in that word level, and but the transformer when transfer based machine translation system. So whenever this thing, so it's basically for the syntax or the semantic based thing. So it's generate the syntactic structure for that source, and then which is mapped to that syntactic structure of the target. So the syntactic tree structure may be mapped with that one with by some set of rules with that one. So in that case, the structure can be mapping with this transfer based machine translation system. And another one is the interlingua based machine translation system. So interlingua based machine translation system is basically for that translated into that abstract language independent representation. Is it in the intermediate system it is translated, intermediate particular format it is translated, and once it translated from that one, it can translate it into the target languages. So all languages translated for that particular intermediate languages, and then it will translated for the any of the target languages for that one. Okay, so these are the rule based techniques are there. So it's basically relies on that particular rules. So whatever the linguist develop that one, and what will be the transfers are there, rules are there. So it was developed by that one. And then is the corpus based machine translation is basically for that that EBMT system, statistical based machine translation, and the neural based machine translation system. So EBMT, of course, that the rule based system, and the why the corpus based system is introduced. Of course, that rule based system, there are some of the unavailability of the good dictionaries also there, and the expensive to construct that new dictionaries, because that manpower is required to develop that new dictionary, new parallel new rules, new rules. So that is also important. And another important part is that there are some limitations also there. So you can build some of the set of rules, but beyond that you cannot prepare for that one. So that is also a set of rules also limited for that one. So that's why it was introduced that corpus based machine translation, so that rule can be learned from that corpus. So whatever that your data sets are there, so data set from the data set it can be learned, and then it can be predict for that one. So example based machine translation was introduced 1980s, around 84. So in that case, so basically it can see the text similarity concept. So of course the text similarity between the text and source and target, so word level and the phrase level. So if it is match, and it can be predict with that only the corpus, not that rules for by the rules. And then the statistical machine translation was introduced, and after that it was actually the most important part is that whatever the estimation can be done, and whatever the parameters can be learned from that parallel corpus. So you have that some huge number of parallel corpus. So from this parallel corpus you have to predict the target sentences. So from this one, so how you can do that one? So you can see that examples, you can see these images, you can see there is a source in the language is the source, and the target is that English. So you can see that English to Hindi bilingual translations are there. So there is an Hindi sentences are there. So how you can translate it? You can see that there is a statistical analysis are there. There must be there. So I'm not going inside that one. So it's very complex calculation. So later on we'll discuss. So translation model can be calculated the probability with this source and target. So it can be calculated, and based on the calculation, so it can predict the various sentences. You can see that once it translated that one, so it can predict that several sentences. Now how we can choose that which sentences is the more probable to that particular sentences. So how we can choose that one? Okay, so but it's very difficult to choose that which one is the more probable for that one. Okay, so in that case, how we can predict that one? So of course it's very difficult to do that one by using that language model. Language model help us to get that best result for that one. suppose we have that four sentences, or if you compare with that one, like probability of C has a red car is the more probable than P red C has a car. So this is the most important part is that thing. So of course that how you can calculate, of course language model will help you to this particular sentences is more probable than this particular thing. So if you get this, of course you calculate all the probability values from that target language, and this target language is monolingual. This will help you to develop the language model. It will not any concern about these source languages. It is only for the target, and it is only used for the language model to check that which one is the more probable. It is not related to that one. So if you have the large number of monolingual corpus, so prediction, of course prediction will give you the good prediction for that one, and then you can choose that, okay, so C as a red card based on this, because it already translated several sentences. So based on that, which one is the more probable, you can do it. So not only that grammatical, but also other structure also it can be formed with that one, and so in that case it is the highest probability, and you can get it from that one. So language model is one of the most application in this machine translation system. So in this machine translation statistically, you can see that there are various types are there. Word level you can do, phrase level translation, syntax based translation, and hierarchical based translation you can see, and it's the most acceptable and widely used for these approaches. So you can see various places it can use for that one. And not only that, the most important part is the phrase level machine translation. You can see that Pushpak Bhattacharya sir, so from IIT Madras, sorry, IIT Bombay. So and his scholar Anup, so they implemented this state of the art for the Indian languages. Some of the Indian languages you can see their labs also. So it's very good in the SMT system. They are getting the good result in Indian languages, basically English to Hindi for that one. So I followed this paper for that one. So now these are the concept of the statistical machine translation thing. So now we move to that deep learning concept that is called the neural based machine translation. So of course that in the neural based machine translation you can see that recurrent neural network is there, so RNN model. So there are various RNN models are there. So of course that we will choose the sequence to sequence model to help to improve this result. And you can see that vector sequence model is there, that is called that whenever you have some images, so you want to generate the caption, so you can use for the vector sequence model for that one. And sequence vector model, that whenever you have some of the sequence text and you want to generate some of the vector format, and then from the vector you can predict some of the positive negative part for the sentiment analysis. You can see that sequence vector model. And generally in this machine translation system we mostly use for the sequence to sequence modeling for that one. And source sentences, you have the input sentences and the target sentences there. So basically you can use for the sequence to sequence modeling are there. So many of you know this part, so I just move forward that one. So RNN model, so you know that basic encoder and the decoder concept. So similar way, so whenever the machine translation system also there, so it also having the similar way to encode that source sentences from the training corpuses, and then decode for that final output of that one. So in this case, of course, the normal basic RNN model, of course, the slow to train and the long sequences, there is a problem for some of the vanishing gradient or these things. So in that case, of course, the LSTM technique is introduced in this case. So of course that can change for that one, for that long-term sequence problem. So somehow it can overcome for that one. And it's basically sequence to sequence learning, and deal with the variable phrases also there. And another most important part is here the embedding. Embedding is introduced because the semantic word can be captured from that one. So previously it was not captured. So once you added with that encoder part, like an embedding layer, so it is capturing more of the semantic relationship between that word. So based on that layer can be introduced here, and then based on that it can be predicted of that one. But here is the again there is a problem here. So in this model, this embedding model also there is a problem. So because for the translation, why this is problem, because all the nodes are generating, and the last node can be moved forward to the encoding to decoder. So once you forwarded to that one, so all information kept into the last node, and then it will forward to the decoder. So in that case, some of the word missing, some of the some part may be missing. So in that case, so in that case, it was introduced. Of course, the attention based layer model also introduced in this case. And this attention based layer model, you can see that all the words give the more attention. So in the encoding part, you can see the all the layer all the nodes are giving to that particular thing. So giving the more attention, and based on that, this attention model is working for that one. And then the once you give the more attention, of course the result is improved from that previous one. So because there are something is some data may be missing for that one, in this case more focus on that part. And but still there are another issues also there in attention mechanism. So during the translation, after the translations also, like decoding part whenever is decoded, so or it also give more attention with that during the decoding time. So you can see the encoder time it's encoded, and then decoding time, so D0 also it can get the information from that various other input nodes from the encoder. So it can compare, and based on that which one is the most probable, in that case it can take that decision for that one. So encoding and the decoding, it is the giving the more attention in this case. So now another bidirectional recurrent neural networks also there. So it is basically work from forward. So previously you can see the one direction, so it can be starting from that both direction, and then we can match with that one, and then we can get the decision somewhere. So it can be used. Some of the research paper I can see that bidirectional recurrent neural network they use, and they got the good result for that, improved result for that bidirectional neural network for that one. And normal and this basic this RNN and that LSTM, that basically that the particular machine translation system, basically the sequential process, and of course it is slower for that one. So in that case, it was introduced the transformer model, and the most important paper, the most cited paper in the machine translation domain also, you can see that Vasman et also it was introduced this transformer model. Not only that one, basically other research paper also they use for that one. So basically this transformer model, whatever that previously happened, so it's basically for that one way processing, so not that parallel processing. So in this case, the sequential model to parallel processing part they introduced for that one. So in this case, what is the most important part? Previously we can see that during the encoding and decoding time, so only for the decoder type can take decoding time, decoder can take the decision with that encoder, but in this case it can consult with that all other nodes. You can see that it can communicate with the all other nodes, all other particular nodes and layers, and then it can decide that what will be the value. So in that case, there are lots of comparisons are there. So of course it will take time, and based on the transformer model can give this sequence to parallel process. Of course it will the much more faster for that one. Okay, so these are the things. So these part are the basically various types are there. Yes, anything else? Someone want to say something? Okay, so these are the basically types, and apart from that, there are various multilingual concepts are there. Neural based machine translation. Previously it was not done in this SMT. So multilingual concepts, like if you want to translate that many to one, many to many, or one to many translation. One to many means like source side is the one, and the target side is the many like many target languages are there. So that can be transfer learning can be possible by using the NLP. And any question? Someone speaker is on. Any question? Okay. Okay, then the transfer learning is very much effective for the low resource languages. Of course, that you can see that there are some of the data sets also available in the Magai, Bhojpuri. So these are the WMT, some of the conferences are there. So you can get it from there. So these are the one of the multilingual concepts. So nowadays, which is very important nowadays for that one, multilingual translation for that one. Another one is that translation for the multimodality translation for that one. Multimodality, like if you have some image and the source with you have the some source text, and if you want to take some of the help with the images, so you can resolve some of the semantic related issues also. So from that one you can use for that. multimodality kind of thing. So image can help you to answer, able to answer that or translate that particular sentence. And there are many researchers work in this domain. So Indian languages as well as that foreign languages also, there are many researchers are working in these multimodality concepts also there. And the zero shot learning, you can see that there are various researchers are working in the zero shot machine translation. So you can see in that Google AI blog, I have taken this picture, and that is basically that do not have the parallel corpus, like or less number of parallel corpus. So how you can do that part? So you based on that transfer learning, you can use from the transfer learning. So based on that, you can use for these zero shot, basically zero shot machine translation systems also. Like of course, there is an important point is here that must be the similar type of languages like Hindi, Marathi, like these kind of things, similar type of pattern. So in that similar type of pattern, so it will give you that good result for that one. So these are the similar kind of patterns. So whenever you can see from that images, I just you can see that both lines are basically the parallel purpose having. Like you see from now, like English to Korea, that is Korean, that is the language parallel purpose there. Then Korean to English is parallel purpose there. Then there is another one, English to Japanese. But there is another one is the Japanese to English. These are the parallel purpose available. Now there is no parallel purpose, so it can be translated Japanese to Korean and the Korean to Japanese, and then another one is that. Okay, so these things they translated with that one. So by using that transfer learning, so that is you can see that Melvin et al. So they use for that one. So zero shot learning. So a few years back, you can see that these three northeastern languages also added with that one. So they use for the zero shot learning. So in Times of India, you can see that Assamese language, Manipuri as well as the Mizo language added in the Google translation. So that they use for the zero shot machine translation system for that one. Okay, so these are the concepts of that one. Now there is an difference between the SMT and NMT, because NMT started 1990s to around 2013 14. So these division Google is state of the art system. So of course there are some problems are there in the SMT, so that can be overcome by the NMT thing. So SMT of course does not provide the end-to-end solution. Of course that you need many configuration. You need to do that every step, like encoding, decoding, everything you have to do the configuration. But NMT, once you start with that one and end with that one, you will get that part. So no need to do anything inside that one. Okay, so if some module, of course that in SMT, if some module is changes updated, so entire translation system to be updated, all the modules to be updated. That is another problem for that one. So that's why it's not that end-to-end solutions. And the long-term dependency and the context analysis problems also there. So SMT, of course, like whenever you have the long-term dependency things are there, so in that case is problematic, lacks SMT lacks context analyzing ability. So in that case SMT somehow it can overcome by using that NMT technique. And of course the generalization part also, like sometimes is a problem for the general the vector numbers representation of that one, various properties that languages that can be possible by the SMT, because sometimes the semantic information if you want to capture by that one, so that is not possible. So in that case NMT can help with that, some of the embedding technique with that one, so we can it can be improved with that one. Of course that one of the most important part, that semantically that word embedding can help to improve the system. So many fields that word embedding technique is using for that one, so that is not possible in the SMT. So of course NMT can use these embedding techniques also there. And the most important part is the transfer learning. Transfer learning is not feasible for that SMT, like you are whenever the multilingual concepts are there. So in that case multilingual concepts is very difficult to translate by transfer that one learning, that is very difficult in SMT. But in MT it is possible for that one to many to many, that can be possible by that one. Okay, so another one is that the difference is that of course that is basically based on the text-based thing. So nowadays, of course, the age of the multi-modality thing, so text, image, speech, as well as how you can do that one. So NMT can help to overcome that part. So these are the difference between that SMT and the NMT system. So now Now you have to evaluate the various machine translation system. Of course, there are some of the standard methodology are there, so that is called the blue score. So bilingual evaluation understudy, tar score, and the meteor and the measure you can do like that. Automatic evaluation system you can do. So sometimes that you can do it by the evaluation by automatic evaluation, as well as the manual evaluation is important for that one. Why the manual evaluation? Manual evaluation, of course, that it is always expensive because you have to involve some of the manpower for that evaluate that one. So automatic yeah, evaluation that you can understand easily by implementing some system. You can easily predict that which one is that best result. You can do that part. So another one is that is called the human evaluation. Human evaluation, the most two main components are called. One is called the adequacy, and second one is the fluency. So adequacy is basically aspect refers to the measure predicted translation quality on the ground of amount of meaning corresponding to the difference translation. Adequacy basically for that meaning of that a particular translation system. So whenever that particular sentence is translated, the meaning is differs or not. So that you can say see that adequacy. And fluency only predicted that it is that particular sentence is well formed or not. That it will not check the with the source. It is only checking the target sentences is the well formed or not. So let's take an example. So we can see there is a sentence. He is a boy, and predicted means wo khel raha hai, and the references is the wo ek ladka hai. So references means that actual output of that one, and predicted means that system can predict it with that one. And now thing is that there is an adequacy and the fluency concepts are there. So adequacy is I'm giving you the adequacy and fluency is the range of like 1 to 5 scale. So why I'm giving the adequacy is 1 and why I'm giving the fluency 4? Can anyone explain these things? Why adequacy I have given 1 and why fluency I have given 4? So let's take the definition. The adequacy means that to measure the predicted translation quality on the ground of amount of meaning corresponding to the reference translation. So meaning can be seen by that one from the source. By the fluency is only predicted that whether that target sentences is well formed or not. It's not relevant to the source sentences. It does not matter with the source sentences. So why it is 1 and why it is 4 in this case? Any idea? Why I'm giving that adequacy is 1 and the why fluency is 4? Is it audible?
Let's see.
So see here the predict. Yes, madam.
Yeah, reference, because you are using one reference for, so this is, I mean, you are finding the
Yes,
adequacy.
yes.
And
Yes,
fluency,
madam. So
because you are measuring in the scale 1 to 5, and fluency is the predicted value. Now, वो खेल रहा है. So I think no, you are not finding the probability, rather.
no, not it is not the probability. It is just human can give the score whatever in his mind. So if is that
Okay.
okay, so it is good or bad. So based on that, it can be given. It's not there is no such rule that it can be given. So like this. Okay. Anyway, so you can see that references part. You can see that wo ek ladka hai. The sentence is well formed. There is no problem in these sentences. Fluency says like that if there is no problem, it will not say that whatever the source sentence has been given. It will only say checking that sentence is correct or not in this
Yeah.
fluency part. So of course that it is the corrected sentences, and it may be also given 5. It's not a problem. 4 or 5 it can be given. So because the sentence is completely correct. But the adequacy is that it can see that wo khel raha hai and wo that is compared with that he is a boy, that is also the different for that one. So of course that adequacy, the meaning is completely changed. So of course adequacy we cannot give that one value. Okay, lowest value we can give. So in this case, so fluency and adequacy we can check for that one by the manual evaluation. So it can really help you that okay, so your sentence is translated sentence is that well form or not. So that is also important. And the meaning and the fluency, that is the most important part of the translation. So like this way we can evaluate by that one. So these are the things for the evaluation part. Now where you can get the data sets, I can tell you that one. So if you this year I have given that I have launched one machine translation tracks, evaluation tracks. Kind of you can see that whatever the data set. So you can see here English Assamese, English Mizo, English Kasi, and English Manipuri, and you can get it in that WMT conferences, the WMT machine translation evaluation that particular conferences. So and first time it was launched because previously no one started with this northeastern languages, basically for the low resource languages, and I got the good responses from the various teams, not only from the northeast, but also some of the good, very good research lab from India as well as from the outside India, US and Europe. So I got the very good response, very good participants. So still is going on. So result already declared, and very large number of participants participated in this track. So and also that a good number of parallel corpus we have released to start working on that one, because many of the cases the northeastern languages not available for that one. So that's why what we did, so we launched this evaluation track or shared track, so someone can get the data and of course they can participate. And now it is not open, but of course that once the evaluation is over, and after that we will give that all the data in this website, so you can get it and you can start working on that machine translation system for that one. And I am also looking for other northeastern states also. I also collaborated with some of the other institutes like Arunachal Pradesh, so Apatani Nisi, so that languages also will add for the next year track for that one. Okay, so these are the things, so you can get it. And but also so some other this is other conferences in the WMT, so you can go to that one, so you can get it English, Hindi Nepali, Hindi Marathi, and English Tamil, so you can get it this kind of data. So we also participated, you can see that top scorer, we also get the top scorer for the various translation systems. So based on the transformer model we participated. Not only that one, another conferences also WAT, previously WMT, another one also like WAT conference evaluation tracks also there. You can get it various Indian languages parallel corpus, so you can start working on that particular workshop, so you can get it that one. Okay, so apart from that, some of the Indian institutions like Amrita University, they launched a few years back, so the English Tamil, English Malayalam, English Hindi, English Punjabi, so they also launched some of the data. So MTIL track was there, so we participated and we also got that result, and we got the good result and top scorer of that one, some of the tracks. And not only that one, some of the others also like languages, Bhojpuri, Maghai, Sindhi, so you can get it from this load SMT, you can get it from that evaluation track. So these are the famous familiar track for that one, so where you can get the data from the Indian languages as well as other languages. You can get it WMT, WAT, and the load SMT, so you can get it for the machine translation system for that one. So I generally follow these things. So some of the data set where you can get it, like Triple H Hyderabad as well as that IIT Bombay, so you can get it. TDIL websites also their government website. So where you can get it the data, so and you can start working on that one. And availability of the tools, so you can get it the various websites. So like SMT for the Moses, you can get it the Moses tool for the computation of the SMT, as well as the NMT, you can get it Open NMT, you can get it that one Marian toolkit, Nematus toolkit, you can get it for that from the various sites, you can get it. And these are the standard state of the art system, so you can change it, and they have given all the source codes also, so you can get it from their websites also there. And the future directions, of course, like low resources are one of the great domain nowadays, so you can start working on the low resource language translation, multilingual based translation, as well as the multimodality based translation. This is the future direction to start working on this domain. So these are the machine translation overview for that one. So now any questions from here? So otherwise I will move that one. So any questions? Any questions from the participant? Okay, so now another just I am giving some of the one of the interesting topics, some few slides, one or two slides, then I can stop and I will take your questions again. So one of the most important studies, I just started with that one research, even you can think about that one. The most important part is the gender biasness. There are lots of gender biasness of that language technologies. Basically the language technology, we are basically finding some of the problems that and not only that one in the language technology as well as the AI also, like there are many things you can face these things. So can you tell me that is there any gender biasness problem? So any applications that you find that there is some gender biasness problem from your mind? Any of the language technologies, not only that AI related things. So AI related issues also, there are some of the gender biasness problems also there. Now I can show you some of the examples. Now you can understand that part. So we have implemented some of the systems. So like my students like Sandeep Kumar Das, so we worked on that image captioning. So his PhD thesis was that image captioning. So he basically worked on the image captioning. So later on we compared with the gender biasness. So now we can see that actually once our system is generated, like these sentences our system generated, but the original exactly caption was a female tennis player shows her the masses kind of, but our system may generate like male tennis player, so which is the contradictory that one. So how the system is male dominated thing, of course that whatever the data set, either it may be biased in the data set or we have to filter in that during the training period. So of course that may important for that one. Not only that one, some other captions generation also the problem. So like you can see like a female is like that wearing the jacket, of course in that case, man can and here also like a boy jumping on that one. So this is the one problem in that image captioning. We found some of the problem in the image captioning. So how to overcome these challenges part? So one of the motivation part is there. And another example is that it's really interesting thing. So whenever we say like the physician, now the physician may be like he or she, which is the mostly biased for that one. You can try with that in the Google translation also, like the physician hired the secretary because he was the overall. Now the secretary is the most of the cases is like C. It is represented that secretary is always referred to that one, and physician always referred to that he. So how which pronoun is basically for that one, that is the bias, either in bias in the data sets or the bias anywhere. So you have to find that one. So that particular thing also in that referential part also you can see that physician it is called the he and the secretary is basically for C. So that in our general mind, if I ask you the similar questions kind of things, so like if the job is like receptionist, so our mind of course it will come to that, okay, receptionist means the female oriented thing. So our mind can be tell like this thing. So similar way, whenever the text is there, so of course the similar concepts also, how to overcome that particular challenges also there. So another issue is there, if you see in the Google search engine, so whenever you search in the like school teacher, so if you see the school teacher, if you search that all the female oriented thing, but if you search in the professors, so you can see the most of the cases images are the professors. So kind of, so this is the just one example for that one. I researched several experiments, so you can see some of the papers I have published in this domain. So you can see some of the images also not classify for that one. So how we can classify, not only that this biasness should not be happening with that one. So there may be some changes, either you can change, you can filter with the data, either filter in that during the training period, during your encoding time. So you have to filter with that one. It should not come with that one. So these are the things happening in that various domain, not only in the translation also there are lots of problems. Like if you see, if you some of the languages is like dependent on gender oriented language. Gender oriented is like some Hindi languages. So whenever you translate English to Hindi, some of the neutral gender also can be male or female. So how you can translate with that? Sometimes it made mistake for that one. So I told you this kind of example can be biasness with that one. So one kind of gender biasness can happen for that one. So that is another challenges or another new domain for the machine translation thing. So you have to either you have to think about that that particular data or particular during the training or the decoding, where you can find this problem and you can remove, and then you can do that one. And it's mostly happening in that nowadays you can see like whenever there are some of the language model also biasness also there. So you can see that there are some of the good papers are there biasness in the language model also. So you can see that there are various biases are there. So there are very some papers I saw that biasness in the language model also. It may happening. It may be depend on that data sets. So these are the small topics. So you can think about that one in future. So you can start working on that one. Okay. So thank you for that one. So I have taken some of the references from the various websites. So various papers. Thank you. So from any questions from the participants?
Any questions? Okay, so shall we move on to the next answer?
Yes. Yes. Samovi is joined.
Yeah. Okay.
Oh, just I'm checking that my scholar is joined or not.
Okay.
Yes, sir, I am.
Madam, I hear he
Okay.
joined.
Mr. Chelli, can you just introduce?
Yes, ma'am. You can hear me?
Thank you.
Yes, ma'am. Welcome to this third sessions of day 4. I would like to reintroduce again Dr. Partha who is an assistant professor at the National Institute of Technology, Silchar, India, since August 2018. He has worked as assistant professor at the National Institute of Technology, Mizoram, from 2015 to 2018. He received his BE degree in Computer Science and Engineering from Jalpaiguri Government Engineering College, West Bengal, and his ME and PhD degree from Jadavpur University, West Bengal. He received dual postdoctorate fellowship, one from the Norwegian University of Science and Technology, Norway, which is funded by the ECSIM, that is European Union, and another from the Marsard University, Czech Republic, funded by the ECSIM and MU, European Union. His research area of research interests and specializations include natural language processing, machine learning translations, semantic textual similarity, text entailment, question answering, information retrieval, image captioning, summarizations, machine learning, deep learning, and machine intelligence. He has published more than 150 papers in reputed journals, conference and workshop proceedings, and 5 patents. He has received 5 research-funded projects from various funding agencies like DST, SCRB, CIFPRA, DAAD, ASEAN, and MEITY. He is also supervising various PhD, PG, and UG students in the domains of natural language processing. He is very active in several international conferences organized by the local and the international associations, institutions, and university. In these sessions, one of his scholars, PhD scholars, Mr. Sajam Babu Pandey, will assist him in demonstrating the experiment. Thank you, Sheriff, for being with us. I give the time and the sessions over to our resource persons, Dr. Prayak, again. Thank you, sir.
Yes, thank you, Sanlep, and thank you, madam. So, Sambabu, you may share the slide. So, he basically explained he is my PhD student and he is working on model, basic hidden Markov model, and if you are interested in more in the quantum also he will explain later, not now. So but he will explain that what is exactly Partha Swiss tagging, how you can do, and this is because this is one of the NLP applications for that one. So basically you can use for the new languages also, you can start working on that one. Last few years I started with that Khasi languages. One of my PhD students also completed in the Khasi Partha Swiss tagging, and one Mizo students also like he is going to submit already over the pre-thesis submission, so he's going to submit on that one. So this is very important domain because once you do it, that Partha Swiss tagging, so after that you can apply for the various NLP application that can be helped this particular POS tagging. So Sambhavi, you can share with that one. You explain some of the part, and then you can explain. yes, you can explain that how they can do with the collab. So everybody, you can open for the collab. So and you will share the code as well as the data sets. So you can work, you can see that part, and then you can do that with that particular data set, and later on you can implement yourself. You can define that tag sets, and then you can do your work. So not only that one, this is the basic concept, because there are some, a hidden outcome model is not new, it's very old system, very old concept, but you have to understand that basic concepts, and later on you can implement for that LSTM model or other model, you can do that part. Okay, Samavu, over to you, so you can explain that part, and you can share your slides, you can do that.
Okay, sir. Thank you, sir. Am I audible?
Yes, yes, yes,
Yes,
sir.
yes, you are.
My screen is visible.
Yes, yes, it is.
Okay. So, good afternoon, everybody. I am Shyam Babu Pandey, a PhD scholar of NIT Silchar. I am doing PhD under the guidance of Dr. Partha Pakray. So today I am going to represent parts of space tagging using hidden Markov model. Basically, parts of space tagging is a fundamental task for the NLP, for high-level NLP applications. It gives the contextual meaning of the words, which will be useful for the NLP applications. And hidden Markov model is a probabilistic model which is able to handle the sequential data set. So this will be the outlines of my presentation. So I start from the introduction to parts of space tagging. So parts of space tagging is a is the process of assigning a specific tag of each words in a given sentences. For example, if this sentence is like the boy sits on the chair. So here we have to assign each word. We have to assign a tag of each words. Like the tag of the is determiner. Tag of boy is noun. Sits as a verb. On as a preposition. The is again an article, and chair is a noun. So in parts just we have to assign a tag of each words. So there are basically two type of POS tags. POS tagging, like first one is a coarse grained POS tagging, where it just given the high level grammatical categories. For example, the sentence is like the cat is sleeping. So it just give the high level of tags of each words. Like the is a determiner, cat as a noun is a verb, and sleeping is also a verb. Here it not differentiate between is and sleeping, giving both as a verb. So this method give the high level of grammatical categories. And next POS tagging method is fine grained POS tagging. So it gives the more detailed POS tag of each words. Like the cat is sleeping. This one. So here is assigned as a verb in BBZ is assigned a BBZ, and sleeping is assigned as a BBG. So here BB is stand for the verb, and each verb has again divided into subcategory. Like is divided into subcategories into Z, which represent is in the third form of the singular noun, and G is sub kind of BB, which G means gerund form of the verb. So this gives the more specific POS tag of each word. So why POS tagging is hard? So main problem when we go for the POS tagging. So the main problem with most of words are more than one pure tag. So depend upon the local context, depend on the local context of the sentences. It words can have more than one pure tag. For example, like the back door. So here the word back, the pure tag of back is adjective, and on my back. So here back, the pure tag of back is noun, and promise to back the bills. Here the tag of back is verb. So according to the local context of the words, tag will be changed. So this type of words creates the ambiguity to how to assign the POC tag. So for that, there are three types of POC tag methods. First one is a rule-based method. Second is probabilistic method, and third one is a deep learning-based method. So rule-based methods use the handwritten rules. Manually, we have to write the handwritten rule for the each POC tag, and probabilistic method use the probabilistic how means frequency of each words corresponding to tags, and deep learning methods use the neural network based methods like for the NLP most of are recurrent neural networks, and its variant like long short term memory, gated neural recurrent by LSTM. So this type of methods are used in deep learning methods. So rule-based methods, it's applied to handwritten rule for the assigning the POS tag of the words. So here we have to write the rules according to the local and contextual information of the each tag, each words. So for example, if we have in a sentence like his MR was there, so we have to assign this as a tag as a BBZ. And if a verb is there and it's ending with ing, so we have to assign this verb as a BBZ. And if a verb is there and is end with ed, so then we have to add the past tense verb. So according, we have to manually write we have to find out the patterns, and according to patterns we have to write the manually rules for this one, for this type of rules to assign the tag of the words. So this type rule-based method is very complex because we need to write manual rules. So it is very difficult for the large amount of data set. So then next one is probabilistic method. So probabilistic methods is basically depends upon the statics and frequency of the words. So it's just you just find out the most frequent used tag for a specific word in the given training data set, and try to predict the tag of a word in the test data set. So there are two type of probabilistic methods involved. First one is a hidden Markov model, and second one is conditional random field method. So probabilistic methods, how it will work. So for example, if a sentence have words like W1 to WN, so this sentence we have to assign each we have to assign tag of each corresponding words. So these are the T1 T2 as corresponding tags, which are we don't know, so this which are the unknown. So in this case we only observe the sequence of words, and we have to find out the corresponding tags. So probabilistic methods, just we have to tags, we have to what is given, and we have to find the corresponding tags. So how can you find? So so each word may contains the more than one tag. So there will be different sequence. There will be different sequence of tags. So we have to find out which sequence will give the maximum amount or maximum probability for the tag. So that will be the tag of the corresponding sequence of words. So, so we applying a base rule of this formula. So we get this one, and PW is common for all the sequence. So it doesn't change any calculation. So we can remove this PW. So then it becomes like PW by PD, and then we apply the chain rule. So which a chain rule will convert we a chain rule we convert like for each words depends upon the previous all the words and all the tags. So this calculation is very difficult. So we need some simplification for this calculation, because for each word we have to calculate the all the previous probability of all the previous words, and we have to calculate the probability of all the words. So for that we need to further simplification. So we further simplified. So for simplification, we just take a assumption like word of probability only depends upon its corresponding PO tag. Its current PO tags doesn't depend on the previous PO tag. So that will be simplified like that. So simplified like that, each word, its probability of each words depends upon its corresponding PO tag. And uh, for the for this part simplification, we take the bigram assumptions. That means each current tag is depend on the only previous tag. So this is the bigram assumption. So its current tag is only depend on the previous tags. So then this formula, simplified formula will be we now we can find out the max of this simplified formula. So this is, so here we need to calculate two probabilities. So first is known as emission probability, and then second one is known as the transition probability. So how we can formulate this with the hidden Markov model? So hidden Markov model is a probabilistic machine learning model which involved two process: observed output and unobserved hidden states. So for example, if we have observed words, here we are observing words, and the hidden state are corresponding its tags. So here we observe words, observed sequences are the words in a sentence, and hidden states will be the corresponding tag of the each words. So what are the required elements for the hidden Markov model? So first we need a set of states, which will be the tag, which will be tags, and an output alphabet, which will be the sequence of words, and we need initial state, which will be the beginning of the sentence. So how is what will be the beginning of a sentence? That will be the initial state, and then state transition probability, which will explain the what is the probability if a tag is what is the probability of a tag if a tag what will if you take the bigram assumptions. Next is the emission probability. So what is the probability of a tag? What is the probability of a tag of a given sentence? So for example, so when we go for the assigning emission probability and transition probability, so we have labeled data. So from that we can find out the emission probability and transition probability. So for example, here some labeled data is there. So here labeled data like Mary, so labeled as a noun, Jane is noun, and Ken is a model, and C as a verb, and Will as a noun. So here, this is the label data set is here. Here we are taking just for the explanation how can you compute the emission probability and transition probability. And so here we are only taking recently we are taking only three tag set: noun, modal, and verb. So first we see how many words, how many times Mary comes as a noun. So for example, Mary comes noun as a four times. So we have to assign each, we have to given statics of each words corresponding tags. So Jan comes noun two times, will comes noun one times. So with the help of this table, we can calculate the emission probability. So emission probability we can calculate. So emission probability will tell given it what is the probability of a given tag, what is the probability of a given tag of a word. So we can calculate by, so we have to give the count of in a data set how many times word wi comes with tag ti and divided by the total count of tag ti. So for example, if we take the Mary as a noun, so what is the probability in data set Mary comes as a noun? So we have to take the count of Mary as a noun and total how many times noun will come. So here total time of noun comes is like nine times noun comes, and Mary as a noun is four times. The probability of Mary as a noun is 4 by 9. So this is the way to calculate the emission probability of each word in the given data set. Then we need to calculate the transition probability. So here there are the three tag set we have taken: noun, modal, verb, and we have taken two extra. We need we have we need to take two extra symbols. One is S for the starting symbol and E is for the ending symbols. Actually, this gives the initial distribution of initial distribution of probability, initial probability of the tags. Tag. For example, S how many times come initially as noun, how many times initially come? So three times. Model how many comes? One. So verb is not coming in times. From here we can see initially noun comes three times. So noun comes three times. So this starting symbols gives the initial distribution of tags, and this gives the end distribution of the tags. So now this is the formula to calculate the count to probability, calculate the transition probability. Like if a tag ti minus 1 is given, so then what is the probability of the tag ti? So it is count of ti and ti minus 1 divided by count of ti minus. For example, if noun is given, so what is the probability of the next tag will be the noun? So for that we take the count of after noun how many times noun will come divided by how many times noun will come. So from this table we can say, so after noun noun will comes one time, and then we can see after noun will comes one time, and total noun comes 1 by 9. So this is the after noun will comes, probability will be 1 by noun. So with the help of this formula we can calculate the transition probability. Now how can you assign the POS tag of words? How can we assign the POS tag of words? So for example, a sentence like Will can spot Mary. So how can you assign the POS tag of these words? So calculate the probability of, just we are taking just two words from this word for the example purpose. So we will take the win as a noun and can as a module. So we can take these two words. So first we have to find out how many times noun occurs as a in the starting, so initial state. So this probability will explain how many times noun occur initial state. Then we will see how many times will occur as a noun. So we will we can calculate by this probability, and then we can see how many times modal occur after noun, and then we can then we multiply with how many times can occur as a module. So with the help of this probability, we can calculate the probability of this sentence will as noun and can as a module. So if you take this sentence to calculate the probability, yes. So if we take this sentence, if you want to calculate the probability of this, someone's mic is on.
Yes, Subhasmita Pani, please mute your mic. Subhasmiti, Subhasmitita
Yeah.
Pani, please mute your mic.
Subhasmita, please mute your mic.
Yeah. So if we take only this sentence, so Will can spot Mary. So all the possible, if you take all the possible combination of this, so it will the total possible, it will 81 total possible for the only for the four sentences. Because if you take will, so will can occur as a noun, can occur as a module, can as a verb. So can is also occur as a noun, module, verb. So total possibility of this total possibility of the 81 total possible sequence will be the 81. So it is a very difficult to compute 81 probability for the finding the which will be the which will be the tag maximum tag sequence of this word. So for that we need some optimization. So Viterbi algorithm is used to optimize the HMM model, because if here only four sentences and three PO stack, then it generates the 81. If sentences is large and tag set is also large, then it will be grows exponential. So it will be very difficult to compute the all the possible probabilities. So for that we need to optimize. We use some optimization algorithm to uh, to optimize the HMM. So Viterbi is one of the algorithm which is used to optimize the HMM. So Viterbi is a dynamic based programming algorithm. So dynamic algorithm basically just calculate the and stored somewhere, and when it requires, it use that stored value. So Viterbi algorithm just work like that. So it computes first. It's find out the it first computes the all the possible probability of a word, and then it store which is the maximum probability, and then we have to revisit that node, and we have to get the final result like rmax of the visited node, which will be the maximum we have to just store in the table. So you first we compute the maximum node or maximum tag sequence of a node of a tag sequence of a word, and we store this into the table. And for the next calculation, we have to revisit that table, and we have to find out what is the rmax, and just like that we have to compute for the all the words, and it gives the maximum value, maximum probability of tag sequences, which will be the final tag sequence of that sequence of words. So for today, we will perform POS tagging on the code mix social media dataset. So code mix social media dataset. So for any dataset, for performing POC tagging, we need two things. First is a corpus, which contains the labeled dataset. So like we can see here, uh, the data set is labeled, so each word corresponding to its tags. So just like that we need a data set which will be labeled, and then we need tag set. What will be the possible tag set of that data set? So so here we are using a code mix. So code mix data set means a data set which contain more than one language. For example, when we are using social media platform, so where we are using most of time code mixed data set, code mixed languages. So a data, social media data most of time contain the code mixed data set. So in this data set, there are three. We are they have taken three different Indian language pair: Bengali English, Hindi English, and Telugu English from the three different social media platform: Facebook, WhatsApp, and Twitter social media text. And these are the these are the data set. These are the tag set of the data set. So there are total 12. So these are the 12 total tag set are there. So these are the tag set, and these are the corresponding description of the each tag set. Yeah. So this is about the theoretical part of the parts of statistics using hidden Markov model. So if any question, then please ask me.
Hello, sir.
Yes.
Very good
Yes.
afternoon.
Okay.
I have question regarding that your previous slide that there you mentioned that three data set you use that Facebook, Twitter, and yeah,
Yeah.
here.
Uh,
So I just want to know that is there any APIs or something available to extract good data from the Facebook platform or WhatsApp? Because
uh,
Twitter is already providing the APIs, but rest of that too, Facebook and WhatsApp, is there any APIs available?
Actually, I have no idea. We have taken from the one. I can share with the link of that data set from where we
Okay,
can
fine.
taken this. Okay.
Fine, fine. No,
So
no. I just want to know about that. Is there any APIs are available that where we can using that API we can extract the data from the Facebook and as well as
no,
the
no.
WhatsApp?
I have no idea about this.
Okay, fine, fine, fine. Thank you.
Yeah. Any question? Yes, ma'am.
Hello.
Yes, ma'am.
So I also want to ask, so you are taking their two languages code mixed. Then
Yes.
you take label text different for Bengali and English, or first do Bengali translate in English, then you
No, no. Already there is Bengali English data set is already there.
or Bengali is taken in a Unix data or Roman data, Romanized.
Romanized form.
Okay,
Romanized
okay.
form.
So then you take
Eh,
a tag set for different language for different like Bengali for different tag set and English for different tag set or same. If there are
Same. No, same.
so then
Actually, these are.
and yes,
Yes. Yes, ma'am. Yes. Ask.
so then there is some ambiguity also and some ambiguous words. Then what you do?
Yeah, so actually we are not doing label. It is already labeled data set is there. I am
So
explaining
you
for the
you
demonstration
take a
purpose.
labeled or you should you on self label the data. Yeah, when we we label the data set, we on self label the
No, no.
data. Then there are some ambiguous words. Both are in Bengali and English, and they have a different part of this tag. Then what we should do?
So for that, we can use for a different tagger for both of them, and then we have to like ensemble approach. We can use different tagger for both of the languages. For you can try for the Englishes and you can try for the Bengali, and then we can combine at them. So as an ensemble method.
Okay, sir.
Sir, I have one question. Hello, am I
Yes,
audible?
yes, yes.
Okay. So, to perform the PS tagging here, you need two things that you mentioned, that you can use the label dataset and that tag set dataset, right?
Yes, yeah.
But the
For
thing is, that let us say, for example, I am having the unlabeled dataset, or
yeah,
we can say the if I am having the unstructured dataset. So, can we perform on that bold dataset POS tagging?
yeah, we can perform with one algorithm is called Baumwell's algorithm. So for then first we apply the Baumwell's algorithm, and then we have to estimate the all the parameters. What will be the emission probability? What will be the transition probability? And then you can go for the
No, no, no. My
P-
question is no. My question is that how we can perform the POS tagging on the unlabeled dataset.
yeah. So for that I'm saying that we have to apply Baumwell's algorithm to estimate the
Can you
parameters.
suggest any library or any packages for to perform the POS tagging on the unlabeled datasets?
Yeah, till now I don't know, but I can suggest for that part.
Okay, fine. But one last question, sir. That
Yeah.
what is the use of the POS tagging? That means exactly. I didn't understand that.
Okay, so it is actually apply for the high level application. For example, if you take the machine translation, so if you are translating English to Hindi, so structure is different. English is following subject, verb, and then object, and for Hindi is structure SBO means
Uh-huh.
subject, then SOB subject, then object, then verb. So use first we should know what is the verb. So for that we need POS tagging. So POC tagging will give the categorize the different words according to categorization. We can translate this. We can define order. So we can translate this the order. We can translate the source to target language.
Is there any similarity between the tokenization and POS tagging?
We can say like that because it is also used for the lexicon analysis of NLP uh, of NLP applications.
Okay, and last question, sir. Sorry to interrupt you because I am working with
Yeah.
this research, so that's why I'm
Okay.
asking the questions.
Okay.
Yeah, I just want that what is the role of POS tagging? Means, is it comes under the pre-processing part or is it the post-processing part?
No, it comes under pre-processing part actually.
Okay, so if I
Like
want to perform the POS tagging on some kind of the unstructured data set, so what kind of the packages can you suggest later after the lecture or after the presentation? So you can suggest me, please, sir.
I have to. Uh,
Okay,
Actually,
okay,
right now I have no idea. Okay, so I have to think about this thing. Yeah.
okay, okay, sure, sure. Thank you,
Okay.
sir.
Yeah. Thank you. Any question? So can I share a collab, Google Collab link?
Sure, sir, sure, please.
Sir, one question. Hello.
Yes. Yes, ma'am.
Sir, I want to ask when you perform tagger, POS tagger on code mix data, you first language identification do which one Bengali words and which one English words, or directly apply part of this tagger?
we can I can explain with examples. Okay, so just open Google Colab. There is already given. How can you identify the which one is the English word, which is the Bengali language?
Okay, okay, sir. Thank you, sir.
So please open with this link.
Sir, it says denied. Please give this as me.
Assessment denied.
Actually, there is need of permission, sir. We don't have need,
Okay,
Yes,
okay.
sir.
access. Just kindly give the permission to us.
Just keep it on. Uh, Now it's okay. Now please open it. Now it is okay.
Not yet, sir.
Yes, sir. Yes,
Yeah?
sir. It is visible now.
Okay, thank you. Okay, so first, yeah. So for first, I'm going to show what is the data set regarding. So, for example, बहुत अच्छा है like that. Please open the data set Facebook Hindi CZ trend 2.txt like that. So this one, actually it is already labeled with there are three level. First one is word. Second one is what is the type of word, which language it belongs. Like bahut means Hindi, acha Hindi. Like way is Hindi. Mixed means like English. So already labeled is there. We actually for the pre-processing we have removed that one. So bahut it's first level is word, then second level is language of that word, and then next is given as a tag set of that word. So it is clear to all what is the format of data set. Any doubt regarding this one?
Sir, repeat please one time.
Yeah.
Yeah. So actually, the data set was had three level. Right now we have removed one level, that is the language of that level. So actually data set is three level. First one is word, then second one is the regarding the language of that word, that is marked like EN for the English, HI for the Hindi, BN for the Bengali. Here we have removed for the pre-processing process. And next one is tagged of that corresponding word. So this is the tag of bahut. Now it is clear. Any doubt? Yes, any question, please ask. Okay.
So it is just one question, sir. It is just for a one sentence or it is for a whole data set?
Whole data set. You
So
can see
how much is the size of data set?
total words are 20,790.
Okay, okay, sir. Fine, sir. So can you take one example related to the unstructured data set? Any, if is it possible for you?
But for right now, I can whatever the model is there, no? So it is
Okay,
especially trained for the level data set.
okay, okay. It is just for a label. Okay, sir. Fine.
No, it is labeled data set as well as it's a natural language. I mean, the sentences we have taken from Hindi or English. So this is unstructured. It is not structured. We are dealing with unstructured language,
Yeah,
unstructured
yeah.
database. Okay?
I think, madam, it's not a unstructured. It's a mixed data set.
So
No, 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 no,
mixed
no.
data set.
No. Structured means you should have a particular structure to store the
Yeah.
data. Are you using any particular structure over here? No. You have simple sentences
Yes.
and they are unstructured, completely unstructured.
Yeah, yeah. Because that is in the text format. So yeah, it comes
So
under the unstructured.
Yeah.
Sir, which you give tag set G for what? You say Bengali, Hindi, and English.
G.
You say na you use three languages: Bengali, Hindi, and English. You give the tag set as a GJ, GB. This
Yeah.
is
So
G for
I
what?
G for
Yeah.
GG for adjective.
No, sir. First, you use G for all tag set. Beginning tag
Uh,
set is G with an underscore, then any tag set, any
okay,
pure.
okay. What is the use of G?
Yeah, yeah.
Uh, Actually, G is for giving one. If a noun is divided into the different type, this is a group. Actually, this data set.
Actually, I am working on Punjabi
Yeah,
English
yeah,
tag set and I am using for Punjabi bird P and then give the tag set. And
yeah. So this.
when we find the English word, just there is the taste word is English, 15 word taste. So I am using eng then underscore then जो भी verb जो भी है.
Okay, okay, I can understand.
You
So
are
this
using
G
for
for the.
all words is G. So I am
So
asking
G.
how it will differentiate Hindi and English words.
Yeah, so G is actually used for the uh, group of words. For example, there is a different symbols. So actually, this is the I have this is the coarse grain data set, and there is corresponding fine grain data set there. So in fine grain data set, G symbols different type of symbols, and in coarse grain we have to group into one G symbols. So we have write it as a G for the group and symbols. If any symbols there, so we have to tag like G symbols. So this is the coarse grain data set. So it stands for CG,
So
coarse
then
grain
you
data
don't
set.
differentiate the languages, which one is the Hindi and which one is English. You give the same group for English and Hindi words.
Okay, okay, okay. I will share with that part. Okay, I don't want to say, but I will share. Okay, just give me 1 minute. and it will be clear. Yeah, just keep it. Yeah, so that one. So that one. So we can see first label is as a word. So this is the first column present to words, and then second column is label of each languages. So bahut is hi, means Hindi, stand for Hindi, and next is for the universe. This is the universal for the both Hindi English, which for the which comes under both in Hindi and English. So it has a universal, denoted as universal. And next one is English. Mix is English. Mixed is English. So we have to assign as a English. And then third column is given as a tag of that word. I hope now it is clear. Yeah, any doubt regarding this one?
Yes, sir. But if we have take HI, then जो भी आपने लिया है tag like HI, B, verb, we can take also this type or not?
We can take, it's not issue, we can take, but for pre-processing we had to just remove that symbols, nothing else for the experiment.
At last step, we have to remove English Punjabi tag.
No need to remove that part. No
Okay.
need to remove.
Okay,
It's
sir.
okay.
Thank you, sir.
It's okay. Any question regarding this one? Data set?
Sir, please last one question. For this identification, Hindi and English words, which model you will use? You are
For?
using for identifying different languages. You have which model you use for identification? You manually tagging or you use some model for language
This
identification?
this data set is not our data set. We have taken from somewhere. So right now I have no idea how to extract this part. Means
Okay,
which
okay, sir.
word is belongs to. But you can we can use using a model like.
So there
Yeah,
are many
we.
models. I want to only ask which one you use. There are many models. It's okay.
Yeah, better to go with recurrent neural network model.
Okay, okay. Thank you, sir.
That uh, that is good. For that, you have to data set also.
Yes, sir, I have collected all data set.
Uh,
Now I have to apply some model for identification. So I am
of
asking which one you use. So I am
so
asking.
you are trying for code mix
Yes, sir.
data
So
set.
I'm using code mixed part of Stacker for English Punjabi.
Yeah, so we can collect it data set from social media platform.
Yes, sir. WhatsApp from Facebook, Twitter.
Uh,
I have
okay,
collected 24 lakh words data,
okay, okay.
24 lakhs, and it
So
contains 1 lakh for 50,000 unique words. And total 10 lakh comments I have.
how do you tag the data set? Means what is the English? What is the Punjabi?
So
How
now
you tag like?
I have only collected data set. I'm just starting work on it. First, I have
Okay.
to identify language. So I am asking which model you use for identification. First, I
Okay,
am doing language identification, then apply part of Swiss tagger.
okay, I got
I'm
it.
just starting the work.
Okay, so you can use you can use R by RNN model. So you have to depress. We have to give the data set. So we have to create two different data set for the language identifiers. First, English, and then second one is Hindi. Then we have to train the language, train the model on these two data in these two data set. Then it can easily identify which language belongs to which one.
Yes, sir, I'm tagging, I'm starting labeling the data. I'm
Okay,
just,
okay.
oh, but not decide which model have to use. So I am asking which model you are using.
Okay.
I'm just tagging the data, labeling the data set. Okay,
Okay.
sir. Thank you.
Okay. Okay. So Google Colab is a Google. It is a online platform for the Jupyter Notebook. So first we need to import the libraries for performing the POS tagging by HMM. So first one is NumPy, which is used for the numerical calculation. It makes numerical calculation easy. And next is pandas. For pandas is used to represent a data in a structured form. And next we will use skill learner model, train test split. So it split the data set into the trained data set as well as trained test data set. And next we are importing time for getting what is how many time it takes to run the model. And then we will, yeah, so total 12 tag set is there. We are taking one extra tag set is starting symbols, because such kind of data set is very difficult to find out the boundary of each end of the sentences, like बहुत अच्छे है dot mix. So it is written in continuous forms. Then how can you identify the boundary of a sentences, means end of the sentence? So for that we are using symbols like if end of the symbols is dot, or like exclamatory sign, or question mark is there, so that will be the end of sentence. So and for the starting we are using one extra tag for the starting symbols. Then after that we split the data set into the test and training part. So here we are using 80% as a training part and 20% as a test part. So we are using training data set as for the find out the emissions and transition probability. And test data set you are using to evaluate the model, you how much it gives the accuracy. So yeah, and now then we find out the how much words. So 17,000 words are for the train, and 4,000 words are for the test. Next, these are the tags of this. So these are the tags of data sets, and this method is used to find the emission probability. And this is for the transition probability. And we can convert this transition matrix with uh, in the pandas form, because it represents the structured way. So this is the transition probability of the data set. So with the help of training data set, we can calculate the transition probability and emission probability. Now we need Biterby to minimize the HMM model. And this is the test data set. Yeah. Now our model will run on the test data set, and it will take time to give the accuracy. Yeah. Yeah. Any question further?
So please share the dataset file so we can also execute the file.
Okay.
Code is not executing.
Okay. Okay.
Sir, one question I have.
Yes.
Uh, if, for example, let us say, is there any mixed word like means, uh, let us say, for example, Hindi, अरे अरे यार ये क्या हो गया? So, this array word is also available in the what we can say in Marathi is also there is that word present.
Yes,
So
sir.
in that case, that pure stacking, how it will work?
Uh,
So what it
it,
will give the
yeah, yeah.
pure stacking for that kind of word?
Yes, so it depends on the local context of that word. For example, I explain with the backward. So
Mm-hmm.
backward has a different PO stack. This is the problem with PO stacking. See, a word
Okay.
can have more than one tag. So how can you differentiate? So with the help of local context. So back, so for example, the back door. So here back is a adjective, and the next
Mm-hmm.
sentence like the on my back. So this is the now here back is a noun. So according to the context of the word, um, tag of words will be changed.
Okay, sir. Okay. Thank you.
How can you share the data set, ma'am?
So share the file on Google Clear.
Google Colab.
Yes, sir. Only sorry, Google Drive. Share the file by Google Drive link.
Okay, with whom? Please provide the email address. How can you circulate this data set to all the participants? My question is that one.
From Google
Share
Drive,
in
you
the
share
chat
the link.
box.
From Google Drive, you share the link, please. We will download it.
So from okay, so please share the Google Drive link so then I can do.
Sir,
Or
on
you
your
can share the link if it is available online.
Okay, okay, that is a good one.
That will be good, sir.
Uh,
but sir, if you don't do any processing on that, if you do any processing on that, then that data will not work here.
of course, it will work. Don't worry. But
So you
accuracy will
send
be
your
changed.
own data, please. You send your own data.
Okay, okay. So I upload in Google Drive, then I will share that. But
Sir, and please show the code which one you use for backward text and forward text.
backward text and forward
Text
text
for,
means
for backward part of Swiss tagger. When we have check backward data for assign the US tagger when there is ambiguity of text.
okay, okay. Okay, I have shared the Google Drive link.
Sir, please give the permission.
Okay. Now please check it. Now it is opening.
Yes, sir. Thank you, sir.
Okay, so at the end we get the accuracy of 77%, and it takes the time around 201 seconds. So please try with uh, this data set. You can go with another data set if it is not, if you cannot get this data, so we can go with another bank data set. This is a standard data set which contain only a three bank data set. So we can access that part also. So I am so we can access the trade bank data set. So for that we have to import the uh, NLTK library, which provides the natural language processing uh, natural language processing applications. So it provides the natural language processing related platform. So NLTK we can you have to import NLTK to process the to process the tree bank data set. Then we have to download tree bank data set. So we have to download tree bank data set. Yeah. And we can download universal tag set of tree bank data set. So it contains the it, yes. Yes. After downloading the tree bank dataset and universal tag set, you need to tag the words. So how can you tag the words? So with the help, so we can tag the dataset. We need to tag the dataset.
Sir, please close the right side window.
Okay, okay.
Code is not visible properly. Thank you, sir.
Then we can see a word, a sentence of this data set. So we can see the sentence of this data set. So this is the universal
Sir, which
tree
are
bank
you
data set.
tracking through this code, analytic data list? It is label the data according to universal tag set
Yes.
automatically, and this is also
No, not,
tagging
not,
the
not automatically. For that, we have to write this code. Not 31 say
universal is a predefined data set, na? Predefined
yes.
tag set,
Yes. This is a
and it
universalist.
also tag the our Hindi and English, Hindi and Bengali words also, or only
No,
English
no.
words.
This is only English word.
Yes. Okay, sir.
You can download Bengali as well also from this analytical data set. But that it does not give the code mix data set. If
Yes.
it gives only Bengali data set, Hindi data set like that it gives. You can download Hindi data set also, Bengali. Yeah, I think now everybody got the data set.
Yes, sir.
Yes.
Hello?
Yes, ma'am.
Yeah, the testing,
Yes, ma'am.
implementing, are the participants implementing?
I think so. Others are implementing.
Yes, they are doing. Okay.
Yeah, anybody got the answer? Accuracy. So I think after performing the uh, POC tagging on three bank datasets, so we get around 93% accuracy, which is much higher than of this dataset. If anyone interested, yeah, you can just we can go with this tree bank dataset also. You got 93%, around 93% accuracy. Till now, anybody have implemented? Yeah, any doubt regarding the code? Anyone has stuck to implement?
So code is processing.
Okay, I think it will take around 3.5, 3 minutes. I think for this data set. It required only three. Suppose if we increase the test and train ratio. Here we are taking the train and test ratio is 80-20. We are using a train set is 80 and test set is 20%. Suppose if
So I'm getting 78 point accuracy.
78 point accuracy.
84, 184. And time takes 91 seconds.
Okay. Okay. What is the ratio of your what is the ratio of data set?
So same that you have
Same.
Yes, sir.
Okay, very good. How did you get this much accuracy? Did you change
No,
anywhere?
sir, I can't change anything. I have do all that you gave code. Nothing changed.
Okay, data set is. We have to check the data set.
So please
Yeah,
share your
yeah,
image also.
yeah. I think this data set, what I have said, that one is more processed, so you get the that much accuracy. Okay, I think everyone get the same accuracy if you are using same ratio of test and test. Yes. Any question?
So please share your mail ID. In future, if I need, I can approach you.
Okay. Okay.
So can I approach you in future?
Yes, maybe you can.
Thank you, sir.
Okay, let's see what if we change the test and trend size. Suppose if I'm taking 70% as a trend size and 30% as a test size. Let's see. Then it will change the number of in word in train and test data set. Tag set will be same. Just run the emission probability and transition probability, and this is then run the better B algorithm and then run on the test data set. So let's see. Now it will take a little bit more time because now test data set is increased.
Sir,
Yes.
have you tried any other model or only this one?
Recently we are trying quantum based model.
Which one, sir?
Quantum based model.
Okay.
Uh,
And which gave the better, more accuracy?
um, a deep learning LSTM model is giving best accuracy, but
Okay.
we mainly focus on the quantum part because we are performing classical for comparison. We have to give one comparison, which one is better. So recently, quantum is a very beginning level, so it does not give so much accuracy, and it cannot process this much amount of data set. Recently, we last experiment we have performed, we only perform with 100 sentences, that much.
Okay, sir.
Yeah, so for that we have to run on the different batches. We have to take the different batches of 100 sentences and then we perform the uh,
Okay.
experiment.
Sir, by 70-30 ratio, I taken 100 of 19 second and accuracy is 77.
Yeah, of course, accuracy will be also decrease. Actually, when we have to perform the experiment, so we need to divide our data set into different test and train and test split ratio. We have to change and see how.
Sir, what are you saying? My system is off for some time.
Okay, okay. I'm saying that when we need to perform the experiment, so we have to uh, test for the different train and test. We have to check for the accuracy of the different test and train split ratio. For example, we have test for the 80-20. We are checking for the 70-30. So just like that, we have to check for the different train and test ratio.
Okay, sir. Okay. So why there are variations in accuracy with same ratio? I got the 77 accuracy and so timing is depend on system, but accuracy
Yeah,
is the same.
actually, you are comparing with accuracy with me.
So I am using same code and same ratio, then accuracy should be same now. Can be different, but
No, no,
accuracy should.
accuracy will be same.
But sir,
Accuracy will be same.
but I
If
got
you
77 point something accuracy with same ratio.
with the same ratio.
Yes, sir.
And what was the your previous accuracy?
Sir, I forgot. I think 78 on 80-20. I got the 78.
Yeah, so actually, yeah, it will be possible because when we split the data set, no, so it will split randomly.
Okay.
You got the point. We are splitting randomly, so maybe it, at this time the data set test data set will be changed. So that accuracy will be will be changed.
Okay.
Here we are not fixing the training and test data set. Here we are splitting. When we split, that will be the random split. So at every time we randomly assign the train and test data set. So it will be maybe changed. Got it?
Yes.
I hope everyone is doing. Can anybody have any confusion?
No confusion. After this session, I will do my own.
So if we can study full code, then we can say anything. We just run the code. Nothing.
Okay. You can change accordingly. You can change your code also. For example, we are just here we are adding the starting tag. There is only 12 tag set is 11 tag set is there, but we are adding one starting symbol which tell how many number of times a word a sentence start with a word. So at that case, it will be very helpful for the initial distribution. To find out the initial distribution, it will be helpful. So you can add end tag set also. How many type a sentence add with a specific sentence, then it will be helpful to give more accurate result.
Please
So
repeat one
according
time.
to,
What are you saying?
I'm saying like that. So here we are adding one extra tag for getting how many a word, a specific word start in a sentence, in a sentence. So for that we are giving the starting symbol s.
Okay.
Okay, so just like that, we can add one symbols and symbols and tag, so we can find out how many times a specific word and in in sentences. So that will be maybe helpful to increase the accuracy. At that time, you can find out no, this much actually this is a probabilistic method. No? So we are trying to find the frequency of each word. How many time a particular word associated with a particular tag. So there may be chance from adding this one starting symbols. We are finding the frequency of starting symbols. So just like that, you can add end tag and you can find out the starting with the end tag, frequency of end words. So I want to response from participants. How much they are getting the accuracy. Anyone?
Sir, one thing or
Yes, please.
sir, which one we better fine grain or a coarse grain test? Which will be better?
Yeah,
Fine.
of course, a fine grain because we fine grain gives the more detail about the POC tag.
But when we labeling the data, it takes more time.
Yeah, of course, we need more time and more depth knowledge about the data set and languages, which language we are using.
But I have 20 lakh words data set. Then it takes so much time.
Okay, of course it will take time. So you should create both. Uh,
First Postgre
course
and then apply find and
Yeah, course that because coarse grain will be more specific.
yes.
Sorry, fine grain will be more specific, and it will give the more and it will also helpful to reduce the ambiguities in the data set.
Yes. So please show code which one you use for when we have ambiguity and we check the tag text backward tag ना
Backward?
मतलब कि जैसे हमारे पास यू कैन अंडरस्टैंड हिंदी
Yes, yes, ma'am.
जैसे हमारे पास दो वर्ड्स हैं उनकी एम्बिग्यूटी है तो हम बैकवर्ड टैग देखते हैं ना उनको क्या साइन किया है बैकवर्ड और फॉरवर्ड क्या टेक्स्ट है हमारे पास कौन सा वर्ड है वो कोड प्लीज दिखा दो
ओके सो मैंने तो कोड नहीं लिखा है आप उसको हेल्प से ट्रांजिशन प्रोबेबिलिटी की हेल्प से एंड इमिशन प्रोबेबिलिटी की हेल्प से आप कैलकुलेट कर सकते हैं with the help of transition probability and emission probability. For example, आप कोई भी वर्ड लो आप उस वर्ड का आपको ट्रांजिशन प्रोबेबिलिटी निकालना पड़े और इमिशन प्रोबेबिलिटी निकालना पड़ेगा and then we apply the probabilities and we can find out the what is the tag of the what is the highest tag sequence highest probability of a tag sequence then we can assign the corresponding
there is
vector.
so many ambiguity in words in two language words like
Of course,
Hindi and
of
English.
course, of course. So actually here I am not going for a specific word. Na?
Okay.
We are doing for the data set. So that's one. And ma'am, you should also not go for the specific. You should like where we are designing a model. So it should be not a specific. It should be generalized for the data for the entire data set, not for the words. That is for okay for the rule based method. If this word comes and this tag is then go for the previous. For example, if take one example. If the in English I am explaining if the is there, so after the most of time noun will be there. Okay, so that's we can take from the rule based method. Yeah, we can take from the probabilistic because probabilistic methods just check the entire data set and see after the how many times noun will come. And it of course it will gives the highest accuracy for that one, highest probabilistic for that one.
But
After
sir,
the
there is some ambiguity in the word na. In Hindi we use also tha, same word.
tha is a different spelling, a tha tha.
This in phonetic typing, some words I use the also.
Yeah. So for that, we have to give the yeah. So if they is like that, so before they there must be verb. हम suppose हम लोग जा रहे थे. If verb comes before they, so we can assign like this they as a what we say like theta is verb in Hindi.
Yeah, yes, yes.
Yeah. So we can assign the verb as. But if it starting yeah before, after that noun is there so then we can assign as a determiner.
Okay.
It's fully dependent upon the data set. How is our data sets fully depends. Yeah, I am expecting the questions from other participant also. Yeah, what is the accuracy of any other participant? No one is answering.
মুই도 আমার দাদাকে পড়িয়ে আমার জানো মুই도 নি আদত হইছে বলি বড় বাত তো বড় বাত খাইব না অস্ট্রেলিয়া না অস্ট্রেলিয়া লাগো আয়া ও কিল সুইমিং মুই ভালো মুই বিলিং লাগিছিল সিনিয়র স্টুডেন্ট লাগিছিল না তো তুমি জানা একটু আমরা সিনিয়র লাগিছিল তো দে আয়া algo tapi dia sudah yang orang mau orang jauh besar dengan pasti karena sing kesana juga mana dulu ya tadi hati ini juga sudah kan atau tadi sudah ini juga itu nampak Cultural mesti jadi atau orang itu
But you have scooty, right?
मुझे गवर्नमेंट दूरी है ना बैठने walking distance walking की जा वाली
Scooty itu teman na coba. Nah,
per month 500
oh ini tadi.
oh I mean no per week 500 like
Participants are trying with the code or
Oh ini nabrajan.
sir I mean what's not
Nabrajan itu saya
color garden post the forest
There-
forest post itu pun garden sekte forest post itu
Kalau hospital punya jauh ni bro. Itu
Budi logo I want
Hello?
Yes, ma'am.
So I think you please go ahead with the remaining.
I think I have done from my side. Any question? Any further questions?
Completed?
Yes, ma'am.
Okay, okay, okay. So any further question? Any questions from participants?
Projekan bol isna sir ini kami isna ini attention
itu project kan pun berarti.
Anyone who wants to ask any
you
question?
give topic and get to whatever we discuss now
Oh, topik ni na.
machine learning
Okay, then you can contact Sam Babu later. You have his mail ID and definitely he will help you for finding, I mean, to help you in your research work. So now I will request Chenli to offer vote of thanks.
Thank you, Sham sir. It's very
Chenli,
helpful for
Yes,
research.
yes,
you
ma'am.
there?
Yes, I'm there, ma'am. Yes, ma'am. We have come to the end of this fifth day, third sessions, and I sincerely convey our thanks from the Nagaland University Department of Information Technology to our resources persons, especially to our today's last session speakers, Dr. Partha and then the scholars, Mr. Sayam Babu Pande, for the wonderful sessions on hands-on programming, on the fox takings using the hidden Markov models. I sincerely hope that all of us have got into what is happening in the current trend, and it will obviously help us in our research